Hi, I'm Moritz from Raven. In this video, I'm going to show you 3 workflows to level up your product design with AI. First, we're going to use an image as a starting point and then iterate with Raven to get a parametric CAD model. Let's jump right in. Here in Rhino, I already have Grasshopper open. And then I'm going to click the Raven button that brings up the Raven UI. Clicking on the plus icon allows me to add an image to the conversation that Raven can reference as a starting point. Now, Raven can use both the image and the text as a starting point to create a parametric model. You can already see Raven is iterating on the model, and I can always see everything that's happening here on my Grasshopper canvas. Now Raven has returned with a message that explains a little bit about the definition. And every part of this CAD model that you see in my Rhino preview is made up of the components that I have on my canvas, including the expressions that make up its shape. And since everything is parametric, I can always go in and play with these sliders to align it more with what I'm looking for. I can also see that there's an issue with how the model is being lofted. If I investigate it further, I can see that the surface from points component is not really constructing the model in the way that I would like it to be. Of course, I can always guide Raven by giving it specific strategies to use. In this way, I can combine my knowledge of Grasshopper or geometry together with Raven, and we can iterate over the model hand in hand. Raven returned and is now successfully using a loft component to construct a surface. To improve the preview, I will go ahead and turn off the preview on most of these components, and then we can see the shape that Raven has created. Now, I'm going to go in and modify all the different parameters that make up this shape to align it more with the image that I want. And whenever I'm ready, I can go in and ask Raven to make edits on the file. And Raven will have the updated context of all the edits that I made, any new components I might have added, and so on. If Raven comes back with some errors, or if I have any problems in my script, I can always say, resolve the issues. And Raven can see those errors and fix them. And now I have a shape that grows thinner at the top. But because I know that there's a graph mapper in this shape, I can go in and wiggle that around to get the shape that I want. And here we go. I have my geometry. It's based on the image as well as my text prompt. And then I iterated alongside Raven with text, but also in the Grasshopper UI. This is a very thin surface, so it's perfect for VESA mode printing on my 3D printer. Next, we're going to have a look at taking existing specifications and turning them into a 3D printable part. Let's jump right in. For this next demo, now I'm going to ask Raven to fetch the specs for a VESA mounting plate online and then construct an ISO-conforming model right here in my Grasshopper. After a few seconds, you can see Raven called a web search to get the exact dimensions it needs and then has already started modeling the plate in my Grasshopper. Raven came back with the basic 75mm mounting plate that I asked for. Now I'm going to ask Raven to expand it to also include the holes for 100mm standard mounting. And you can see Raven performed the simple edit to add the 100mm mounting holes. I'm going to keep going and ask Raven to. If Raven goes off in a direction that I know is wrong, or I want to refine my prompt, I can always just stop Raven, and then by hovering in the bottom right corner of my last message, I can edit it. And then if I click the arrow key, I'm going to be asked if I also want to reset the canvas state, or I want to keep the edits that Raven just made. I'm going to say yes and revert the canvas state to the moment when I send that message, so I can have another run at constructing the mounting tab. I'm going to ask Raven to narrow it down to 5mm thickness, keep the 40mm width, and add one standard hole in its center. Now the last little edit, flip the hole to be protruding through the tab in Y direction. Great, you can see Raven is cutting a hole, and if I adjust the preview, I now have my proper mounting tab hole. Since this is a part for 3D printing, I'm going to ask Raven to avoid the hard edge between tab and plate, and instead add a smooth transition. And there we go. Raven has managed to add a smooth transition between tab and plate. 3D printing parts allows you to do very interesting things with densities and grids. So next, I am going to add a hexagonal grid on the back of the plate that covers it entirely, but is contained at its borders. Now, if I turn off the preview, you can see the grid is contained, but it doesn't quite cover it yet. So I can adjust the size of the grid. Now I will say, move this geometry to the other side of the plate, make it 2 millimeters wide and extrude it by 1 millimeter. Now we have the extruded grid, but actually, so I'm now going to ask Raven to make the grid thicker if it's closer to the holes. You see Raven extruded both the hexagons and the grid lines I made, but I only want the grid lines, and I want them to grow thicker if they're closer to our holes, or further away, they can be thinner. So now I'm going to go in and reduce the hexagon size. I wanted the strands to grow thicker as they're closer to the holes, so we have more strength there, but Raven really seems stuck on the reverse. So I'm just going to run this prompt again after I adjusted it a little bit and hope that Raven fixes it this time. Now I'm looking around the script to see where the logic in the error is, but I can also let Raven work in the background. And it seems Raven is still convinced that it already got the logic correct, so I'm going to ask it again to fix it. And this time I actually got it, so I'm going to increase the thickness of the strands, update the previews, and then here we have the fixture ready to be printed. In another workflow, I'm going to show you how to reference existing geometry and apply complex patterns or perforations. So I'm going to select this half of a car hood here, and then create a surface component and say set one surface. Because I want to have clear control over where those perforations appear, I'm going to also add a curve that I let flow along the side of the surface just a little bit. And I'm going to reference that in Grasshopper. I also have a mirror plane ready to go. Now I will right-click on the curve and give it a nickname. And then I will ask Raven to project the control curve onto the surface, then flow a few cool perforations around it. Avoid any heavy computation. It's just a reminder to Raven because these perforation scripts can get really heavy and I want something quick and easy to just try out. So Raven returned and it added some perforations that flow along the curve. Let's turn off the preview so we can better see what Raven made. So these are the perforations. Now we have a graph mapper, which means we can change how the perforations look, and also their maximum radius is just a slider here. So I can really control what those perforations look like on my car hood. And now I'm going to ask Raven to add more rows to it. Add rows of circles, less for lower radii and more for larger ones. So we can really get that 2D shape made of perforations. So Raven has returned, and I can see it created the rows, but they're sometimes overlapping, so I really wanted to also dynamically space out the curves. Please dynamically space out the curves so they never overlap, so longer rows just extend further out. But you can already see where these rows are going to get us, and the different patterns that we can get using the graph mapper. Please align the rows perpendicular to the curve. Don't flow along it, but outwards to the left and right. There we go. Now this is exactly what I was looking for. We have these perforations, and as we change the graph mapper, we can get very dynamic patterns. And of course, it's still all parametric, so if you want to change the density of the rows, we can do that right here. Or we might want to change the graph type to something that we have more control over, like a Bezier graph, and then really build out a smooth looking perforation. I think I kind of like the parabola look. And of course, these perforations are still linked to my control point curve. So if I take the curve and pull it up here, my perforations will move, and I have great control over how I want them to look on my car. When I'm happy, I'm going to ask Raven to apply the cuts and mirror the shape. And here we go, Raven mirrored and applied the perforations. If I bake out this geometry, I can turn off the Grasshopper preview. Here I have my perforated car hood in Rhino. Those were the 3 workflows that you can use as a product designer with Raven AI. Go from an image to a model, model complex fixtures, and apply complex perforation patterns. Thank you for watching. Come join our Discord to see how other product designers are using Raven and to get all the tips and best prompts.